The twin towers had a perimeter of steel panels hoisted up and bolted into place. Each panel had 3 box columns about 14 inches square, cross-connected by spandrel plates. After the plane hit, the fires were burning out and cooling down.
The flames on the south tower, which appear to be getting lesser and lesser, is where the smoke is getting progressively lighter and lighter, indicating that the fire officials are getting closer to putting this fire out.
But then, about 7 minutes before its final destruction, almost an hour after the plane hit, molten metal was seen coming out of the northeast corner near the 80th floor. The red-yellow metal poured from the tower along with a shower of sparks, and looked like steel in a foundry. And there were many eyewitnesses that described molten steel.
You'd get down below and you'd see molten steel running down the channel rails.
Later, we learned of very small spheres of iron found all through the dust. That iron must have been molten, allowing surface tension to pull it into those spheres. NASA took photos indicating very high temperatures days after the event, and Firewise professors were perplexed by melting of steel beams. And so we have direct video evidence, eyewitness accounts, forensic evidence, photographic evidence, and tangible evidence all corroborating temperatures high enough to melt steel. The media told us the intense fire, more than the impact, caused the towers to collapse. It melted the structural steel. But there's a problem. Office and open-air jet fuel fires cannot melt steel. The National Institute of Standards and Technology said that the maximum air temperatures was about 1800 degrees or 1000 degrees colder than what's needed to melt steel. So what can melt steel and explain all the evidence? Independent scientists began to piece that evidence together, and they suggested some type of thermitic material must have been used as part of the tower's demolition. Thermite is a mix of iron oxide and aluminum, and thermate is a mix of thermite, barium nitrate, and sulfur. But NIST ignored much of the evidence of molten iron or steel. They provided their own theory for that yellow metal pouring from the tower. NIST understood that molten aluminum is silver, not red-yellow. So NIST developed a theory to explain the color issue, stating, the molten metal was very likely mixed with large amount of hot, partially burned solid organic materials, such as furniture, carpet, partitions, and computers, which can display an orange glow much like the logs burning in a fireplace. But there's a problem. Office materials like furniture, carpet, partitions, and computers are less dense and won't mix. They'll float on molten aluminum, like this coin on liquid mercury, and then burn off at those temperatures. And steel at those temperatures won't melt and would sink, and therefore won't mix with the molten aluminum. NIST never conducted any experiments to confirm their theory, but others did. Dr. Stephen Jones proved the NIST molten aluminum and furniture mix theory wrong. Then an independent peer-reviewed report was published which found explosive red-gray chips all through the dust and positively identified as nanothermite or superthermite. Unlike conventional thermite, this stuff is a very high-tech explosive and confirmed what the independent scientists had been saying all along. But NIST refused to test for explosives or its residue and ignored standards such as NFPA 921 guidelines. The corporate media attacked all the evidence of thermitic material found. Let's watch.
If thermite melts through this steel column, the theory of a thermite-controlled demolition may have some validity. While the truthers insist that more explosive super thermite could have been used in the tower demolitions, testing conventional thermite can illuminate this physical process and answer a simple question. Can thermite of any type burn through steel beams? Despite 175 pounds of thermite packed around the steel column, it remained undamaged.
Mythbusters says, the events of 9/11 will not be allowed to be debated and discussed. And they barely managed to melt through the roof of a car with a half a ton of thermite. And the debunking websites say, the thermite would have also needed to cut sideways. Not an easy feat for thermite. You see it's a powder which burns chaotically, maybe with some device, but no working device has been proven to me to work to cut a vertical column. So we are led to believe that thermitic material cannot melt steel, cut steel horizontally or vertically, and would take massive amounts to do any real damage. So who's right in this great thermate debate? NIST and the media? Or the independent researchers and scientists who stand nothing to gain? It's time we conduct our own experiments to answer these questions. Can thermitic material melt steel? Can it cut horizontally or vertically? And does it take massive quantities to do any real damage? Many wide-flange beams were also used in the construction of the towers, connected in a variety of ways. Could thermite cut or weaken such a connection? Using the same beam from my eutectic steel video and another 12-inch beam, I proceeded to make a double-angle welded connection, which I set up on some 8-inch concrete slabs. I could not obtain nanothermite, so I made small quantities of old-fashioned thermate, which is not considered an explosive, with ingredients that are legal and readily available. Thermate is difficult to ignite, and ordinary fuse is not hot enough. But a magnesium strip, which burns white hot, will ignite the thermate giving off heat and white smoke. NIST mentions bright white flames. Almost immediately, a bright spot appeared at the top of the window on the 80th floor. An unusual flame is visible within this fire. The upper photograph of a very bright white flame stands out. And let's listen to an eyewitness who was there.
I was on the 81st floor. Tell me what you saw and heard. I had 40 people in there, just an explosion. There's a light flash out my window, my whole doorway to the entrance in my office blew open.
Could these white flashes be some sort of igniter for the thermitic material? In addition to giving off heat and white smoke, thermate produces lots of small spheres of iron. These iron spheres are a natural byproduct of thermate and not from any steel. Just like those iron spheres found all through the dust. I'm an engineer who designs and builds things, and I'm certainly no explosive expert. My first problem was to find a container that could hold the thermate long enough to melt the steel while not melting itself. I didn't think that steel would work as a container, so I had to improvise using some normal roof tile that I cut in half. I then had to devise a way to hold it against the connection. I used strong magnets and a spring tooth from a hay rake to press 5 pounds of thermite on each side of the double angle connection. I lit the thermate. And it did absolutely nothing to the steel connection. Maybe thermate cannot melt steel, and maybe National Geographic was right. But the steel did not melt, meaning that perhaps a container could be made out of steel after all. Using an ordinary steel box tube, I had a slot milled along one edge. Welding the bottom and using clamps on the top to hold the powdered thermate in, I bolted it to a steel beam vertically. I called this device my thermitic box cutter. With only 1.5 pounds of thermate, or less than 1/100th of what the National Geographic experts used for their experiment. Not only was I able to melt steel, but it also sliced a vertical cut. So I made a slightly larger thermitic box cutter and used 2 3/8 bolts drilled and tapped on one side of the connection. It only took a slight twist to break it completely off. I noticed as the thermate burned, it tended to lose its cutting power, perhaps because it could expand into the area where the box cutter previously burned. So I built a piston-driven box cutter using a compressed car hatch piston. I added sheets of tungsten to minimize the burnout and allow the piston to slide better. I then bolted my contraption to the flange of the column and ignited the white-hot magnesium. It appears that not only can thermate melt steel, but it can also cut vertical columns. So why bother to use incendiaries like thermate and not high explosives? I think it's all about keeping things quiet before the main event. Using thermate may take longer to weaken such large columns in the towers, which may be why we see the molten steel several minutes before its final destruction. Here is less than 1 3/4 pounds of thermate, or 1/100th of what National Geographic used, quietly burning. And here is less than 4 pounds of thermate focused on the web of a wide flange. Which can also be set up on a vertical column. The web was reduced in thickness with gaping holes, thinned to almost razor sharpness, with a Swiss cheese appearance. NIST rarely mentioned explosions except to say that they didn't exist. Instead, they used the politically correct terms pressure pulses and dust puffs. Repeated pressure pulses. The sources for the pressure pulses and or dust puffs are unknown. The series of pressure pulses. Perhaps we are seeing a pressure pulse in this video. Rather than using a mechanical piston to maintain volume, I segmented my box cutter with steel plates hoping to get a more uniform burn, but got some unexpected results. Can thermate make pressure pulses and or dust puffs? I guess it can. But why waste all that thermate and energy cutting the columns? Why not attack the weakest areas instead? Can thermate cut bolts? I guess it can. But what if just the head of the bolt is exposed rather than the nut and the threads? Can thermate be configured to cut just the bolt head? I guess it can. And without any evidence on the other side. I don't think that something like my piston-driven box cutter was bolted to the office walls, or trash bags full of thermite used. It's more likely that any pre-weakening thermitic material were hidden inside the perimeter box columns. I had a replica of a segment of the WTC box columns made up. And like the Trade Center iron workers, I bolted the segments together. It made 2 sets of my 2 bolt blasters, placing them in the access hole. Let's listen to another eyewitness.
Like, it sounded like gunfire, bang, 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 and then all of a sudden, 3 big explosions.
Is it even possible that thermate could do this? I guess it is. I made a 4-sided box cutter split in 2 pieces so they could be inserted inside the column. I held it up on the burnt-out bolt blasters and thought I could hold it down with magnets. Let's see what happens. I think my box cutter blew about 30 feet up, consuming valuable energy and trimming my tree in the process. Nevertheless, the inside of the column was cut about 3/4 of the way through. Were thermitic devices or maybe explosive nanothermite sprayed inside those box columns? I'm not sure. And I'm not sure why this handhold is so large. Or why the side of this box column looks like it's blown outward. Or why 3 columns have a more intense glow, followed by 6 columns that don't, followed by another 3 that do. But I have an idea. But I do know that it's impossible for jet fuel or an office fire to melt steel or iron, which means the official story is wrong. Yet despite all the overwhelming evidence of explosions in molten steel, some people will still believe that this is aluminum and believe Building 7 fell naturally from an office fire. But those people will believe anything. Meanwhile, the government lies while the media hides the truth about 9/11.
Can thermite of any type burn through steel beams?
I guess it can. Isn't it time we use physical science rather than political science to investigate 9/11?